of minutes now just to get to know each other. So in just a moment, you're going to see some polls that are showing up on your screen. If you could take a few minutes just to complete those polls so that we can learn a little bit about the people who are here, that would be very helpful to us. Thank you. Noticing a wide range of roles and grades that people are working with, and a wide range of people, student populations, which is great. I'm excited that we do have such a range, and if you're not sure, that is always welcome. All right. It seems as though most people have finished completing those polls. One additional question, I would like for you to please set your status to either agree or disagree with the following statement. I have used the EIE in-school curriculum, engineering adventures, or engineering everywhere before with students. So just trying to get an understanding of where people are coming from here. I'm seeing a lot of people who have not used EIE or Engineering Adventures or Engineering Everywhere with students before. I'm also seeing some people who have, which is great. Hopefully this will still be helpful to all of you as we go on. You can go ahead and clear your statuses as we get into this next section. We're just going to go over the goals of this online session, which is on our engineering and out-of-school time curriculum, Engineering Adventures, which is for 3rd through 5th graders, and Engineering Everywhere, which is designed for 6th through 8th graders. The session goals are to help you become familiar with Engineering Adventures and Engineering Everywhere curricula and their resources. We're also hoping to help you feel prepared to use the EIE website to enhance your engineering education pedagogy through the use of our free online educator resources and apps. In order to do that, we're going to take a quick overview of the mission and history of Engineering as Elementary. We will also spend some time learning about the specifics of implementing Engineering Adventures and the kinds of activities you can expect to find in those units. We'll quickly explore the concept of technology through a modified version of one of the activities found at the beginning of each of our Engineering Adventures and Engineering Everywhere units. Then we'll explore how to implement Engineering Everywhere in your setting. We'll do a quick what is engineering activity. We'll wrap up by exploring some general resources that are available on our website that can help you with facilitating our curriculum and with engineering education in general. And then we'll have some time to answer any burning questions you might have about Engineering as Elementary, Engineering Everywhere, or Engineering Adventure. So what is Engineering as Elementary? In 2003, our founder, Christine Cunningham, decided to work with a group of researchers from Tufts University to learn about what students already know about technology. In this first study, we wanted to assess students' current knowledge of what they believe a technology to be to help us better develop our curriculum. Hence our What is Technology activity that we'll be exploring later in this webinar. In our study, we gave students this image and had them identify the items that were technologies and items that were not technologies. This is actually just a sampling of those. In the poll on the left, please select the items that you think are examples of technology. Lots of answers rolling in here. All right, tech team, can we show our participants what they think? And then you can compare that to what students thought. The graph that's on that slide shows the student perceptions of what was technology before and after participating in an engineering is elementary unit. So those blue bars show the number of students who answered correctly as to whether something was a technology or not. And those red dots are what they thought after participating in engineering as elementary. So they were very successful at identifying natural items as not technologies, and very successful at identifying electrical technologies as such. But those non-electrical technologies that we see in the middle are a little bit more tricky for kids. So after doing that, that naturally made us curious about students' perceptions of engineers. So we conducted a separate second study in which students were asked to draw what they believe an engineer looks like. And we found that students had some interesting ideas. They thought that engineers build buildings. So we see that Alex drew this lovely picture of an engineer with a sword and a screwdriver building a house. We saw that engineers build bridges and roads. So we see in this one that our engineer has a screwdriver, but also has a set of blueprints. Engineers fix cars, engines, and machines, possibly because that word engine appears in both of them. Engineers use or fix computers. And while most engineers will tell you this is a big part of their day, this is not the only thing that they're doing throughout their day. And of course, engineers drive trains, which, while related to vocabulary is correct, it's a very narrow definition. What you may have noticed is that most students did not see engineers as designers that used their skills and knowledge related to math and science. They didn't see that engineers were particularly creative. They were mostly just technicians or mechanics, a view that's not only incorrect but incredibly narrow. The fields that they described were largely male-dominated, and almost all of the pictures were of male engineers. In fact, the only female engineers that we had as results in this were from students who had a female engineer as part of their life. They also did not describe engineers doing anything related to biology, chemistry, or environmental studies. So we developed Engineering as Elementary, which is a research-based, standards-driven, classroom-tested curriculum that integrates engineering and technology concepts and skills with elementary science topics. We wanted to make sure that our curriculum addressed those misconceptions and aligned with current standards like Common Core and NGSS. And as we did our preliminary research, we also tested our curriculum after 2 to 3 years of piloting in the classroom to ensure that the content and engineering skills were seamlessly integrated and could be easily implemented by teachers who did not have science backgrounds. And that testing was great. You can see in these images that students were incredibly engaged in their design challenges. And there are many opportunities for engaging in engineering, both in school and out of school. So we developed 2 offerings we'll be talking about for the rest of this webinar. So let's go ahead and dive right in. Engineering Adventures is our first curriculum. It is designed for 3rd through 5th grade students in out-of-school time programs. Units are intentionally structured to provide background knowledge constructed through hands-on activities. Once a child has learned about technology and the engineering design process, that knowledge is solidified through activities that explore the materials, science concept, and design principles of a particular challenge. Unit culminates in an engineering showcase where children present their final designs to their peers. Research has shown that this structure works well in a variety of out-of-school time settings, including after-school clubs, summer camps, and community groups. The units are 6 to 10 activities long, each of which takes about 45 minutes. They're available for free online, and the curriculum guides and materials are also available for purchase through our online store. All of these units are intended to engage kids in the engineering design process, give a multicultural and real-life context for a challenge, and give kids the chance to work in groups and share their work. This mission statement, I feel, really encapsulates what we believe are the most important aspects of engineering adventures, which is to create exciting out-of-school time activities that engage 3rd through 5th grade learners in engineering and the engineering design process. We want to positively impact the attitudes of kids about their ability to engineer. After someone has gone through one of our units, we hope that they recognize that they are engineers. But we also wanted to make sure that our curricula matched the challenges of working in an out-of-school setting. Often kids are there one day and not there the next. You might have a very mixed age group. So we wanted to make sure that what we were doing did its best to meet those needs. Our target audience, as I've said, is kids in 3rd through 5th grade, but after-school attendance is rarely that cut and dry. So we've been to several sites where there have been kids from kindergarten through 8th grade all in the same room. And sometimes those same kids show up from week to week, and sometimes it's more of a drop-in model. So we wanted to make sure that kids could be successful regardless of whether they'd been there the last day or whether this was their first time showing up. We also weren't bound by standards and tests as we were creating our out-of-school time curricula, so we wanted to make it fun and engaging. And one of the ways that we did that was by setting the context for why we're completing an engineering challenge. So Engineering Adventures uses email from India and Jacob, a globe-trotting brother and sister duo that sets the context by sending letters to students. Those letters can also be found as audio clips, and we're going to listen to one now.
Hi everyone! Amadou came by this afternoon and we told him about the goals that we decided on for our recycled racers. He said he's also working to create his racer. He reminded us to think about the track we made as well as our goal. What type of racer would be best to help us reach our goal and roll over the track? Luckily, even though all the kids here are competing in the Recycled Racer Rally, everyone is willing to help one another. It turns out that engineers do this all the time. Sometimes one group has a great solution to a problem that works well with another group's solution to a different problem. We met up with Amadou and his friends to share our ideas and get some advice from them. We used their advice to help us create our first racer designs. See if you can work together with some of the other groups. With their help and the engineering design process, we know you'll be able to make your racers go far. Good luck, India.
So that was just one letter from our Go Green Engineering Recycled Racers unit. And as you heard, it helped to set the context for the design challenge that students would be completing. India and Jacob also have an Instagram account, so you can follow them to see what kinds of technologies they're finding out in the world. We love interacting with people via social media, so please feel free to follow us or to post to us if you're interested in doing that. As we mentioned earlier, there are 10 units so far for Engineering Adventures. Those 10 units take place around the world, and students fill up their passport with stamps from all of the places that India and Jacob have traveled. Those units cover a variety of engineering fields, and we're just going to do a quick overview of what each of those units are and what their final design challenge is. So one of our first units is Hop to It, Safe Removal of Invasive Species, which is a mechanical engineering challenge set in New Zealand where students design a cane-toed trap. For Bubble Bonanza, students participate in a materials engineering challenge to design a bubble wand, and for that, India and Jacob traveled to California. Next, India and Jacob traveled to Thailand to learn about package engineering with their friend Ratna, where they engineer an aid drop package in our unit to the rescue. That package must protect and identify its contents to someone who might not speak English. In Shake Things Up, our earthquake engineering unit, India and Jacob traveled to Haiti to learn how to design a building that can withstand a magnitude 7.0 earthquake. In Liftoff, engineering rockets and rovers, India and Jacob had the good fortune to travel to both the Jet Propulsion Laboratory and the International Space Station to engage in an aerospace engineering challenge to design a model rocket that can fulfill a mission to another planet. That letter we heard earlier was from our unit Go Green, Engineering Recycled Racers, which is set in Senegal. Students design a toy car out of recycled materials. They also design a track to participate in the Dakar Rally. Then we have the Sky's the Limit, Engineering Flying Technologies, which is an aeronautical engineering challenge set in the Ames Lab and the NT Quadrant. They design a flying technology that can be used for exploration of a remote area. Music to My Ears is our most recent unit. It just came online a couple of weeks ago. It's an acoustical engineering challenge set in Mongolia, where students design an acoustical device to amplify music for use in a festival. Slippery Slope, Engineering Avalanche Protection Systems is coming soon. It's an avalanche engineering challenge set in Peru. Light Up the Night is also coming soon. It's an electrical engineering challenge set in Iceland, where students design a device that mimics the northern lights. Engineering Adventures has students go through a 5-step engineering design process as they work to solve their engineering challenges. This EDP, or engineering design process, is the same one used for our in-school curriculum and has 5 steps because it's easy for younger children to remember 5 things, just like their 5 fingers. They ask, imagine, plan, create, and improve their technology to meet their goal. As we mentioned, all of our work is extensively researched to ensure that we're meeting our goals as curricula. Our research suggests that participation in this program leads to a greater understanding of the engineering design process and improved attitudes towards possible future STEM careers. The graph that you're looking at right now looks at student attitudes about being a scientist and being an engineer before and after engaging in one of our out-of-school time units. We also make sure that our curriculum meets the needs of educators. So we ask that they give us some feedback. This feedback is from our Bubble Bonanza unit. It tells us how educators felt about implementing it in their classrooms, but we get pretty similar feedback for all things. So let's get back to interacting. At the beginning of this session, you all created this beautiful word cloud about what technology is. And I'm noticing some themes as I look at it. Lots of thinking about opportunities and connections. It's all about innovation and learning. I see man-made as one of our bigger words, tools and computers. Those are answers that are pretty similar to what we see both from teachers and from students. And I can tell that you guys have a lot of experience working with our curriculum in advance because I see some of those words are a little bit higher order, which is great. So we're going to now do a highly modified version of one of our preparatory activities that's found in several of our out-of-school time units that's meant to help students develop a common understanding of what technology means in the context of engineering activities. It's called, What is Technology? You're going to pretend that I have just given you a brown paper bag like the one you see on screen, and it has an item inside. Inside your bag is a spoon. With that in mind, I'm going to ask you to answer a couple of questions about the material properties of that spoon. So go ahead and take a minute to answer those 4 questions. Seeing full consensus on it being human-made, on it being plastic. Lots of people think it could be made out of a different material, and so far everyone's saying it could be used to eat without a mess, which is definitely something that spoons don't always do for me, but that is their goal. So now what I want you to do is think about how else this spoon could be used. So coming up is a poll. You can type in any answer you'd like to this one. So how else could we use that spoon? Ooh, egg race, that's a new one. Building tool, excellent. To garden, small shovel. These are great answers. Keep hair out of face. Oh, I'm interested in that one. Musical instrument, absolutely. This is a great list of technology, or of ways to use this technology, which I probably should have not said just yet. So at EIE, we use, thank you, at EIE, the definition we use for technology is anything human-made, an object, system, or process that is used to solve a problem or fulfill a desire. This definition is intended to help children distinguish between the natural and human-made worlds and aligns with national standards. We know that this is sometimes a tricky definition, especially for adults, but for kids we found this really works well. So with that in mind, go ahead and set your status to agree or disagree with this question. Is our item a technology? And almost everyone has agreed that it is. Excellent. So now that we've had an opportunity to interact a little bit, let's dig into our other curriculum. Engineering Everywhere, which is designed for 6th through 8th grade out-of-school time programs. In this curricula, context is set through videos. Again, it's available for free online with materials available for purchase in our online store. Engineering Everywhere, because it is intended for older students, does take a little bit longer to implement. It, again, has 6 to 10 activities, and each is about an hour long. On the left side of this slide, you can see the engineering design process we use for our middle school learners is a little bit larger than the one we use for elementary school kids. The reason for that is because we wanted to expand some of those steps to have students have an explicit identify and investigate step instead of just an ask step. We've also separated create into create and test to make sure that students understand that those are separate. And we've added an explicit communicate step because that's a really important part of middle school design challenges. We also found that middle schoolers thought that India and Jacob were just a little too young for them. So we set the context for our engineering design challenges in Engineering Everywhere through videos which include interviews with professionals related to the field. We're now going to watch a clip from one of those.
Some engineers have developed prosthetic devices to help animals with missing or injured limbs. I wonder, how can engineers use the engineering design process to develop these prosthetic devices? What are some of the challenges they face? And how do they know that their design will meet the animal's needs? To find out, I visited an engineering company called 3D Systems, where Tara Anderson and her team are designing prosthetic devices for a dog named Derby. So tell me a little bit about Derby and what makes him unique.
So Derby's this adorable pup who was born with a deformity in his front legs, and so they didn't fully develop, and so poor little guy couldn't walk or run. He needed some help.
To help Derby, Tara and her team used the engineering design process, which is a series of steps that engineers use to solve problems. First, they identified Derby's need, a prosthetic device that would give him full function of his front legs. A prosthetic device is a technology that is designed to replace the function of a missing or injured body part. She explained that Derby originally had a cart that he could use to get around, but that it didn't let him run or interact with other dogs very well.
And it wasn't until after that I had already agreed to foster him that I started making connections with, like, we've got tons of engineers, I've got every technology at my disposal, we have a whole medical division to this, surely we can help them. I mean, that's really what design and engineering and any of this is really about. It's about improving things. And so to be able to see Derby, who could not run at all, and now to be able to see him sprint across
So that gives you a little bit of an idea of what the context setting videos look like. So we're going to just go over what our 10 units for Engineering Everywhere are. First, we have Here Comes the Sun, Engineering Insulated Homes, a green engineering challenge where students engineer a shipping container home that helps maintain a constant temperature. Next, we have Don't Run Off, Engineering an Urban Landscape, where an environmental engineering challenge where students design a model city that integrates green technologies. Next, we have Crash Test Engineering, Designing Helmets. This is a personal favorite. And students design a helmet that helps protect a model brain. We have Engineering Ice Cream, Designing Food Processes, where students are improving the process for making ice cream. Go Fish, Engineering Prosthetic Fishtails, is a biomedical engineering challenge, and that video we just watched is a clip from the context sitting video for that unit. It's About Time is a mechanical engineering challenge where students design timekeeping devices that they can use. We also have Outbreak, Engineering a Pandemic Response, which is a biomedical engineering challenge where students have to design things like an antiviral. From Plants to Plastic, students design a bioplastic, which is a chemical engineering challenge. Growing Up, students create a vertical farm, and It's in the Bag. Students draw inspiration from nature to create bio-inspired gear for a team of scientists that want to study specific animals in interesting locations. Coming up, we're currently developing 3 new units on planetary science in partnership with NASA and Northern Arizona University. One of those units will be for Engineering Adventures, and 2 will be for Engineering Everywhere. So if you're interested in pilot testing, we will have 2 rounds of pilot testing. And make sure you're subscribed to our newsletter if you're interested in that, so that you can learn about those opportunities. The newsletter is wonderful. It has lots of information about resources and other things that are coming down the pipe. So this is our curriculum development process. We have the initial development of a unit. We do 2 iterations of pilot testing. We revise it, and then we finally release it for the public. And that helps us take it from students thinking things like this to students feeling much more successful and seeing the fun and exciting aspects of engineering. So earlier in our What is Technology activity, we explored the idea of how a plastic spoon is a type of technology. So now I want you to imagine that we have that plastic spoon again, and my crazy landlady is finally allowing me to plant a tree in my backyard. Now, clearly the plastic spoon I have isn't the best tool for the job, even though we did say that it could be used for digging. Luckily, we have the magic of our imaginations to help us. In the poll that's about to come onto the screen, I want you to share your suggestions for how we could transform this technology to solve my new problem of planting a tree. Some excellent suggestions so far. Put together many spoons. That's a new one. Larger electric motor, metal spoon, bigger digger. Connected to a backhoe. Yes, I'm seeing some very interesting magical solutions to this problem. Excellent. Waited for some magic beans. So what you're all doing as you come up with these improvements is acting as engineers. Engineers use their knowledge of math, science, and ergonomics to help design or improve existing technologies. So there was mention of longer handles, larger bowls, making it so that it was maybe a little bit more pointed, changing the material. These are some of the common solutions that we have to this problem. As we said, this is what an engineer does. An engineer is a person who uses his or her knowledge of materials and their properties science and math, and their creativity to design new technologies or improve existing ones. EIE defines engineering as the process that uses one's creativity, understanding of materials, math, and science, and the engineering design process to design technologies or improve existing ones. So you can see that those two are very closely related. So now we're going to take a look at some of the resources that we have available for you as an educator. First, as hopefully you already know, you can access our website by going to EIE.org, or you can go to engineeringadventures.org or engineeringeverywhere.org. There you'll find the engineering unit materials, introductory activities, our iOS apps, a professional development guide, videos, and pilot opportunity information. From the main page, you can click on either the Engineering Adventures or Engineering Everywhere subheading. You'll be able to identify where you are because that will change the selection that is highlighted. We're going to focus on just Engineering Adventures for now to have a jumping off point. From the Engineering Adventures tab, you can navigate to our curriculum units, and you'll see all of the units that we currently have available. From there, if you click on any unit, it will take you to that unit's information page, which gives you a quick overview of what students do in that unit and gives you a place to download that unit for free. If it is available for purchase as a pre-made binder, you'll be able to see that you can buy the unit or the materials there. If you're looking for additional resources for your unit or for Engineering Adventures in general, you can navigate to the Resources tab. There you'll find quick downloads of other tools we've developed that we think may help you. We've also developed 2 apps that are available for free for iOS devices. So those Apple devices, these are where you're going to find those. One is a QR code scanner that kids can use to hear the messages from the duo in Engineering Adventures Aloud, like that audio clip we heard earlier. And the other is a What is Technology flashcard app. This is something that you can have kids do just to practice their knowledge that they already have learned. Those are available for download from the iTunes App Store. And you can find it by searching for Engineering is Elementary there. Additionally, if you're responsible for training a staff of educators, we've developed some resources you can use for professional development. You can find the complete professional development guide and accompanying PowerPoint on our website. This is what it looks like. And this is a complete guide, so you'd be able to download this and give that training tomorrow. So with all of that, I'm happy to answer any questions you have about either of our 2 out-of-school time offerings or any of our online resources. Not quite done here, so if you have questions, I'm happy to answer those, but otherwise just hold on for a few minutes until we see if anybody else has the same question. Absolutely, Yasmin. That's an excellent question. We have seen the 6th through 8th grade units successfully scaled down to 5th grade. And that is something that if you're looking for a little bit of support in doing, you can contact our team and we're happy to do this. You do not need to be trained to deliver lessons beforehand by a trainer. You're welcome to read through that professional development guide, but these are intended to be very easy to use. That form that you're asked to complete before getting the download is just so that we have a little bit of information about you before you get started. The Engineering Adventures Planetary Science curriculum is still in development. So if you just sign up for that newsletter, we'll be looking for those sites to pilot coming very soon. I've just been reminded that I don't need to rush through all of these questions. Carrie, I assume you are asking if the 6th through 8th grade units can be scaled down to 3rd grade. And the answer is that they can be scaled for any grade. It's just going to take a little bit more adaptation on your part. They are intended for older kids, but it is very successful in many grades. And are there resources to expand the 3rd through 5th grade units for 7th through 8th graders? We don't have any resources specific to that, but we do imagine that that would be something that would be possible. In fact, we've seen those units used with kids up through 8th grade. And it shouldn't require a lot of adaptation to be able to do that. So if you have further questions about that, please do reach out to us. Marie, that's an excellent question. High school curriculum. Unfortunately, we don't have a curriculum that's specifically designed for use in a high school setting. That said, we have seen our middle school curriculum successfully used in a high school setting. So if you're looking for more information about that, I think we have a blog post on our website about that, or you can reach out to us. Jennifer, I think that doing 3 to 4 lessons in one day would be ambitious, but it would be something that you would be able to do. Some of the units are more well adapted to that. It would depend on whether you need additional prep time before you complete the 2nd or 3rd or 4th activity. Catherine, you cannot purchase specific materials from us without purchasing the whole kit, although if you're having difficulty sourcing specific materials, please do reach out to our store team. We have an extensive spreadsheet that shows us where we source individual materials from. And so that's something that we can definitely help you with. Lorna, there is not an overlap between the EIE in-school curriculum and the after-school curriculum. None of those activities are found, except the preparatory activities, are found in both sets of curriculum. So if your students are doing engineering is elementary in their school day, you can still have them engage in engineering is everywhere, or engineering adventures or engineering everywhere out of school. Rebecca, is there a pre and post survey that an after-school site can administer? Rebecca, I'm actually not sure of the answer to that. That's something that we definitely have in our in-school curriculum, but I'm not sure where you might download that from on our website, so I can try to find that information out for you and get back to you. I believe we probably have your email address, so we'll be able to reach out to you afterwards with information about that. Jennifer, I think, let me think about this. So prosthetic tails and recycled racers. I think that both of those should be doable. I would recommend reading through the units. I'm pretty familiar with them, but still working on my out-of-school time familiarity. Cheryl, I'm so sorry I didn't answer that earlier. We do offer some trainings and workshops on the West Coast. For West Coast workshops, we actually partner with WestEd. So if you're looking for information about workshops on engineering is elementary on the West Coast, they would be who I would reach out to. We also do periodically offer scholarships that would help pay for travel to come to the East Coast. But we don't usually do out-of-school time trainings on the West Coast. If you're curious about our professional development offerings as far as out-of-school time goes, we really do recommend you check out that out-of-school time professional development guide that I mentioned towards the end. I see one more person is typing, so I'm happy to wait and see that. Do you feel a unit could be done as a group activity on a science night? Ooh, I feel like there are a number of activities from the unit that could be done as group activities on a science night. We highly recommend having students work in groups throughout all of our units. But I think that getting through an entire unit in a single night could be really challenging unless you were doing some build-out activities in advance. So if you had an opportunity to pre-teach some of the content in your school setting, then you would be able to have some expert students who could support groups in that science night setting. Otherwise, I would look really carefully at the activities you were considering. Elaine, I see that your hand is raised. If you have a question, can you please put it into that question box? Okay. So we're going to go ahead and wrap up. It seems like I've answered the questions that you do have. So after this session, I want to know a little bit about how you feel about teaching engineering in your setting. So on that adorable picture below, go ahead and mark where you feel you are. Are you nervous? Are you terrified? Are you calm, confident, or are you fearless? I'm excited to see so many people who are labeling themselves as confident. That is, oh, it's been pointed out to me that you might not know where to find the pen. I'm so used to this platform that sometimes I forget. All the way on the left of that image, you'll find the pen. If you just click where it says marker, that'll give you control. I'm glad to see that nobody is terrified. That poor wolf looks very scared about engineering, so hopefully that means that none of you are very scared about teaching engineering at this moment. So again, please do feel free to contact us or follow us on social media. Be sure to sign up for our after-school engineering update newsletter to get information about piloting any of those upcoming units on aerospace engineering. I just wanted to make you aware that this was our very first ever open to the public webinar. And we'd love your feedback on how we did so that we can improve for next time. We're always working on that improved step of the engineering design process. To help that happen, you'll be receiving a survey link in your email. If you could complete that survey, that would really help us make sure that we're meeting your needs as educators and make sure that our offerings are the best that they can be.